so let's go over here. Let's go to my notes. Cool. All right, so this is what you were asking for. So that's how you write out the answer. So pretty much you rewrite this and you say what is the probability is equal to. So the probability is equal to 0.9901. Any question for that first example? All right, so let's do the second example. So for the second example, we want to find the probability that z is greater than or equal to negative 1.3. So for this one, the equal sign is meaningless to us. It doesn't add any value. Because if you kind of remember in the beginning where I said the probability that the z-score is equal to exactly a value is always equal to 0. So it doesn't matter if you include a value or don't include the value, the probability will still remain the same. So if it does have an equal sign, there's nothing special about it. You're not gonna have to do anything to account for that inclusion. You treat it the same way. So for this one, we'll say, well, will you draw this out? The middle right here. So if you look at it, this is negative 1.3. So that means it should be somewhere here on the left-hand side. So put negative 1.3. Right. So just remember the reason why I put 0 in the middle, because that's our mean. So that's why it could kind of help you out to determine if the z-score that you have should go on the left side or the right side. Since negative 1.3 is smaller than 0, that's why I'm putting it on the left-hand side. If we would have gotten a positive value, you put it to the right-hand side because a positive value is bigger than 0. All right. Any question in regard to how I put negative 1.3 to the left of 0? All right. So if you look at it, it says the probability should be greater than or equal to negative 1.3. So if you look at it, it's pointing to the right-hand side. So that means we shade the right-hand side. And we're going to go ahead and we're going to go ahead and figure out what the lower bound is, the upper bound, mu, and sigma. Right. Any question in regard to the drawing so far? All right, so let's do the lower bound. So for this one, what will be the lowest value that possibly was shaded? And you can just type it into the chat. Yeah, good. So you put negative 1.3. So if you look at the upper bound is the highest value that possibly gets shaded. But if you look at it, it keep on going to the right-hand side. So that means it go to positive infinity, which is just 10 to the 10 power. And then if you look at it, since they gave us the z-score, we know mu is equal to 0. We know standard deviation is equal to 1. All right, so that's what we're going to put in the calculator right now. But any question in regard to how I got the lower bound, upper bound, mu, or sigma? All right, so right now what I'm going to go ahead and do, I'm going to go ahead and transition over to the calculator. For that way you can see me entering the value. Share. So first thing we're going to do, we're going to hit the second button. And the way I know is on second, if you look at it, it has an arrow pointing up. So go VARS, go to normal CDF. For the lower bound should be negative 1.3. The upper bound should be 10 to the 10 power. Mu is 0, sigma is 1, and then you go to paste. Right, so we get our final answer to be probability z is greater than or equal negative 1.3 at 0.9032. So let me switch it over to my notes for that way you can be able to see that. All right, and that's it for that second problem. Were you typing in, was it giving you an error for the last problem? Okay, so most likely the error that you might be seeing, if it is giving you an error, I'm pretty sure you're not using this button. So you want to use the negative below the 3. So if you look at 3, if you look at the number below it, you want to use that negative. Because, like, oh, let me see this. If you do put this negative, it will give you a syntax error. Well, talk to me after class and I'll try to figure out what's wrong with it. Because usually that's the most common error, that if you use don't use a negative below the 3. But if you are doing that, you talk to me after class. All right, so let's share. Okay, so what I want you to do, I want you to try doing these next two problems. So try finding the probability for z is greater than 2.27, and go ahead and find the probability that z is less than 3.57. So try go ahead and do that. Once you get the answer, you just type it into the chat, and I'll let you know if you got it right, or if you still need a little bit more work on it. All right, so let's try to go ahead and do that. So I already did the two drawing. So if you look at the 2.27, you want to do pretty much shade the right-hand side because it says greater than. So if you look at it for the lowest it could possibly be is 2.27. The upper will be pretty much infinity, but since we don't have a button for infinity, you put 10 to the 10 power, you put mu is equal to 0, sigma is equal to 1. And if you do that, you get 0.0116. So this area over here is 0.0116. And that was it for that first one. For the second one, it's a little bit different because now you're shading the left-hand side. So the lower for that will be negative 10 to the 10 power. The upper will be 3.57. The mu will be 0. Sigma will be 1. And then if you do that, the probability for that one should be 0.9998. Right. And that's how you find the probability for those. So for this one, if it's pointing to the left or pointing to the right, they just mean either going to negative infinity or positive infinity. But that's it for this, well, for these last problems. Any question in regard to the last two problems? All right, so let's go on down. All right. So up next, we're gonna go ahead and we're still doing the same thing. We're finding the probability for a standard normal distribution. The only thing different for this one, we actually have two cutoffs because we want to find the probability it's between these two values. So for this one, if you look at the example I have, we want to find the probability is between negative 1.57 all the way to positive 0.47. So if you look at my drawing, you did negative 1.57 all the way to 0.47. So what we want to do, we just want to find the probability of the shaded area. So what we're going to go ahead and do, we're going to go ahead and figure out the lower, the upper, mu, and sigma. So if you look at this lower, pretty much for this one, we have a cutoff in the lower end, which is negative 1.57. So we put lower is negative 1.57. But now if you look at it for the upper, you also have a cutoff. So we have a cutoff of 0.47. Our mu is equal to 0. Our sigma is equal to 1. All right. Any questions so far? I got the lower bound to be negative 1.57. Upper is 0.47. Mu is 0. And sigma is 1. Okay, so I'm gonna go ahead and transition over to my calculator. For that way you can see how I enter it, but it should be the same as before. So you go to second, you go to bars, you go to normal CDF. For my lower, we're gonna change that to negative 1.57. For my upper, we change it to 0.47. My mu and sigma remain the same. I go ahead and enter it. And the answer for that question should be 0.6226. And that's the end of that first problem. So for this one, it's actually a little bit easier because you don't have to worry about the negative infinity or positive infinity because you have cutoff in both ends. So if you have cutoff in both ends, it actually should hopefully be a little bit easier. compared to when you have to deal with negative infinity and positive infinity. Any question for that first problem? All right, so up next, what I want you to go ahead and do is go ahead and do this next problem. So I want you to find the probability that the value is between 2 and 2.17. Yeah, so for this one, you should be getting 0.007. And that's it for that last problem. Any question for that last problem? Okay. So far what we've been doing, we've been getting a Z value and converting it into a percent. So that's what we've been doing lately. So what we're actually going to do now, we're actually going to be doing the reverse process. So for the next portion, which is right over here, we're going to start off with a percent. And we want to find what is the Z value that correspond to that percentage. So we're going to be doing pretty much the opposite. So we're going to be starting off with a percentage. And what we're going to do, we're going to find what is the Z value that correspond to that percentage. So let's go ahead. So for this one, we're going to be given this percentage. And what we have to do, we're going to have to find what is the Z value that correspond to that percentage. So for the next couple of problems, we're going to be given the percentage. And what we have to do, we're going to have to find what is the Z value that corresponds to that percentage. So let's go ahead and do a problem. So if you look at this one, it says probability of Z is less than A, which is equal to 0.04. So if you kind of remember the problem that we just finished doing, they will kind of be given like this. Where they gave us the Z value and we had to find the percentage. But if you kind of notice now, they're giving us the percentage, but they're not giving us what this number is equal to. So that's what we're going to be working on right now. We're going to be working on how can I get those percentage? Well, sorry, how can I get that percentage given that my A value has to be a certain Z score? So first thing you want to look at, you want to look at the inequality, which is saying less than. So since it's saying less than, that means we want the left-hand side. So if I draw this, normal distribution or standard normal distribution, 0 always go in the middle. So if you look at it, it says less than, so that means we want the left tail. And if you see right here, they're telling us it's equal to 0.04 or 4%. So I know this is 0.04. So I know the percentage, but what I want to do, I want to find out what is the Z-score that correspond to that percentage. So I want to figure out what is this Z value equal to? Because right now we don't know, and that's what we're going to hopefully find out once we're done with this portion. All right. Any questions so far what we're doing? All right. So one thing you should kind of know that will help you out for these type of problem, for that way to know if you're entering it correctly or not entering it correctly, you want to see which side of 0 does it fall under. So if you look at the z-score, we're saying it's to the left of 0. So since it's to the left of 0, we automatically should know we should be getting a negative value. So anything that we get, it should be a negative value. If we get something that's non-negative, we know we did something wrong, because since it's to the left of 0, we should know it should be a negative value. All right, so if you have your calculator, make sure you have your calculator out, for that way you can kind of follow along on what I'm doing. So the first thing you want to do, go to second and vars. So it's actually the same thing that you do to go to normal CDF. Then what you want to do, since we're doing the opposite, that's actually the inverse norm. So we're going to be doing inverse norm. So if you look at inverse norm, it's asking me for three things. It's asking me for the area, it's asking me for mu, and it's asking me for sigma. For area we already know is 0.04. So one thing about the area for the TI 83 or 84, it always wants the probability to the left side. So you always have to adjust what you're looking for to tell it that you want the probability of the left side. Because if you give it the probability of the right side, it's not going to give you the answer that you want, because the calculator is always going to assume you're always giving it the probability of the left side. So mu is equal to 0, sigma is equal to 1. We go to paste. If you have a TI-83, all you have to do is enter 0.04, comma, 0, comma, 1, close parenthesis, plus press enter. And we get that is equal to negative 1.751. And that's how you pretty much get a percentage and convert that into a z-score. Any question for that first problem? All right. So let's go ahead and do the second one. So if you look at the second one, it says finding z when the probability area is known. So it says find the probability of z is less than a, which is equal to 0.05. So once again, for this one, we're given the probability, but what we have to do, we have to find the z value that corresponds to that probability. So once again, we're going to draw this out. We're going to put 0 in the so if you look at it, it says less than, so that means we want the left tail. And they tell us this is now equal to 0.05. So what we want to do, we want to find this z value. So we want to find what that z value has to be in order for the left side to have 0.05 or 5% of the data set. Any question in regard to that drawing so far? All right. So I'm going to transition over to my calculator, and we're going to do this in the calculator. So we go second, vars. We'll do inverse norm again. So we're going to change it to 0.05. Mu stay the same, sigma stay the same, and we go to paste. And if you look at it now, we get z is equal to negative 1.645. And that's the answer for the last problem. So for this one, we'll say A is equal to negative 1.645.
And how do we write this answer?
All right. Let me transition over to the, and there you go. That's how you'll write it. So you can either say A is equal to negative 1.645, and that should be good. Any question in regard to the last two? All right, so let's do the last problem.
So why would we wouldn't put z equals, we would put a equals?
Yeah, because if you look right here, since it says find A, because right now we're putting A as like a dummy, because we don't want to put Z as less than Z. So we're just saying, what does Z have to be less than? And since it has the A right there as just a holder, we could put A has to be negative 1.645, because if you substitute A in, you get that.
I see. Okay, so we would just write a equals, not the probability.
No, because you wouldn't put, because for this one, we don't care about the probability because we already know the probability of 0.05. We only care about what does that A value has to be in order to capture 0.05.
Gotcha. Okay.
Yeah, good question. All right, so if you kind of notice so far, we only have been focusing on the left side. So in the next problem, we're going to focus on the right side. For that, we can see what's different between if you want to find the probability to the right side compared to the left side. All right. So if you look at the reason I know the right side is because it says greater than. So greater than means the right side. So that means we're going to say, well, let me put 0 right here. And since it's on the right side, you say the right side. So this is going to equal to 10% or 0.10. And what we want to do, we want to find what is the Z value that corresponds to that. So if you look at the Z value, is on the right side of 0. Since it's on the right side of 0, I should automatically be getting a positive value. So I should know that any value I get should be a positive value. In order for me to get the positive value, I have to enter it correctly into the calculator. So if you kind of remember in the beginning, I said the calculator for the area, it always wants the probability of the left side. So if I know the probability of the right side is 0.10, and if I know that this entire thing should add up to 100%, I have to find what the probability of the left side will be. So if the probability of the right side is 10%, that means the probability of the left side should be 0.90. And this is the area we're going to be using when the TI-83 asks us for an area. Because the thing is, the TI-83, it doesn't know better. It is automatically assuming any area that you enter is always the area to the left-hand side. So if you put 0.10 as the area, you're going to get the wrong answer. So any question in regard to that before I transition over to the TI-83?
So when it's greater than, we're basically finding the complement and then we subtract it to find the number that we need.
Correct. Okay. So you're just finding the area of the complement and then yes, enter that for the area. So we're going to press on. We're going to go second bars. We'll do inverse norm. And so if you look at the error we got with 0.90, so you put 0.90 there, mu and sigma is the same, and you press paste. You press enter. And now if you look at it, now we get a positive number. So we get A is equal to 1.0 1.282. And that'll be your answer for the last one. Any question in regard to how we got 1.282?
Yes. Uh, so aren't we finding this A for all the other stuff of what we don't want?
Well, if you kind of imagine A is the cutoff. So it's cutting off the 90% from the 10%, isn't it?
Yeah, but I mean, I thought there would be an extra step on this one because I thought we're finding everything that we, from what I'm seeing, we're finding what we don't want.
Well, it's not, because technically we're not finding what we don't want. It's just that the calculator, the way the calculator is, if I would say area is equal to 0.10, the way the calculator will see it, that we want to find this.
Gotcha. Okay.
So in order for the calculator to give us what we actually want, you have to tell it what this entire area is, because the calculator is always assuming that you're giving it the area to the left-hand side. So technically we are finding the area that we want. The only thing different that we can't tell it is 0.10, because the way the calculator would think of what that 0.10, it would think that it's the 0.10 on the left tail, not the 0.10 on the right tail.
Yeah, I just calculated the 0.1 and it's actually just the negative 1.282.
Yeah, exactly. Because I'm going to show that now. Yeah. So like if you were to go back to the inverse norm, and if you do 0.10, if you notice, like the only thing different between 0.90 and 0.10, 0.10 would give us negative 1.28, because now it's assuming it's the left tail, versus if you put 0.90, now it's assuming it's the right tail. So that's why it's important that you always give it the probability the left side, because the calculator, unfortunately, it always sees it that way. Unless you have like the super new calculator where it will actually ask you, is this the left tail, right tail, or center? And you can actually tell it. But if you have one of these old calculators, you do always have to put the probability of the left side. All right, but that's it for that third example. Any question for that third example? All right, so if you kind of know there's two problems there to try, and technically we already did one of them. So try practicing on A and B. For that way, you could become expert on converting percentage into z-score. So do try doing A and B right now. But technically A we already did A. A is just negative 1.282. So try doing B. Cool, good job. So yeah, so for B, If you kind of can see what I have so far, I have the standard normal distribution. The reason why I know the standard normal distribution because 0 is in the middle and because we want to find the z value. So if you look at it, it says greater than a, so that means you want the right tail. So you want the right tail, and what you want to do, since you want the right tail, the calculator only see the left tail. So if you wanted to find the left tail, you have to find this blue area. So you have to find that if this is 0.30, then this has to be 0.70. So since that is 0.70, what you want to do is do inverse norm. And then for area, you want to enter 0.70. Mu will still remain 0. Sigma will be 1. And you should get that A is equal to, what was that? 0.5244. And that's it for that last problem. Any question in regard to the last problem? All right, so let's scroll on down. Okay. So the next part that we're going to be doing, we're still finding z value when we know the percentage. The only thing different now, we want the percentage of the middle portion. So if we want to find the percentage, well, if we want to find the z value for the middle portion, technically what we want the same b value. Well, we want the same z value. The only thing different, we want one of them to be negative, the other one to be positive. So say, and I'm just making this one up. Say if we have a percentage right here, we want to find a z value. So this could be -1, and this could be +1, that between those two values. So the only thing different between the two z value, one of them has to be negative, one of them has to be positive. So we want two z value with opposite sign that capture that middle portion. So that's what we're going to be working on for the next certain amount of problem. I'm going to show you how to do it. We're still going to be using the inverse norm, and we still want to use the idea of the inverse norm that we want the probability to the left tail. So let's first do this problem. So for this problem, it says find B for the middle 95%, or probability that negative B is less than Z, which is less than B, which is equal to 0.95. So we want to find two z values that have the opposite sign that capture the 95% in the middle. So we're going to put two brackets, and we're going to say in between those two brackets, we're going to have 95%. Well, actually, let's do this in decimal. So we have 95% in between here to here. So what we want to do, we want to find what did this B have to be and what did this B has to be. So far, everybody go with that picture. All right. So unless you have like the newer calculator, you need more information other than this. Because if you have the newer calculator, which you could do for the inverse norm, you put area of 0.95 and you select center. But some of you might not have that option. So I'm going to show you how to do that. So I know 0.95 is in the middle, and I know this entire thing should be 1 or 100%. So what you have to do, you have to figure out, like, if 95% is in the middle, how much percent is left over? So if we have 95% in the middle, that means for the leftover, well, you have 0.05. Because if you do 1 minus 0.95, you get 0.05. Everybody good? Where did that 0.05 come from? All right. So if you look at right now, we have 0.05 that's left over, but we have two tails. So what we want to do, we want to get that 0.05 and evenly split it up between both tails. So if I want to evenly split it up between both tails, what I'm going to go ahead and do, we're going to get 0.05 and we're going to divide that by 2. So if you do 0.05 divided by 2, you actually get 0.025. So that means for this piece over here, this piece is equal to 0.025. This piece over here is equal to 0.025. Any question in regard to how or where did the 0.025 come from? All right, so no question. All right, so if you remember from the inverse norm always wants the probability of the left tail. So what I'm gonna do, I'm gonna just use this tail over here. So that means we're gonna be using this probability. We're gonna be using 0.025. So for the inverse norm, for the area, we're gonna tell it the area is 0.025. So I'm gonna transition over to the calculator. So that way you can see how I enter it. So we go second, bars. We'll do inverse norm. For the area, you just change that to 0.025. Mu is the same, sigma is the same, so you gotta paste. And if you look, we get negative 1.96. So we go, this is negative 1.96. Everybody got on the negative 1.96? All right, so let's transition over to my notes. All right. So if you notice, I have the negative 1.96 over here. So if you remember, we're trying to find a B value or Z value that pretty much they're exactly the same number. The only thing different is they have different sign. So if that's negative 1.96, then that means this one has to be positive 1.96. So that means if I find the area of negative 1.96 all the way to positive 1.96, you should have 95% of the data set. So D2 Z-score, the area in between these two Z-scores should be 95%. And that's it for that one. So for this one, we'll say B is equal to 1.96. Any question for that first problem? All right, so let's move over to the second problem. Let me go ahead and draw this out. So if you look at this one, it's telling me now the middle should be 80%. So right here, we're gonna put 0.80. So now we have to find what is the leftover. So how much more do we need to make it 100% or 1? So if we know 80% is in the middle, then we know there's a total of 20% left over. So we have 0.20 that's left over. But since we have two tails, what we want to do, we want to split that up between the two tails. So we go 0.20 divided by 2, and you get 0.10. So that means this is 0.10, this is 0.10. But technically, we only care about this one, because this is the one that we're going to use in order to find what is that Z value equal to. So what I'm going to go ahead and do is go ahead and transition over to the calculator. So over you go second, bars. You go to inverse norm. So for my left toe, the left toe is equal to 0.10. So you put 0.10. Mu is 0, sigma is 1, and we'll go to paste. We'll press enter. And we'll find negative 1.282. So that's what we got for the left toe. So the left toe z-score is negative 1.282. So if I want to find the right toe z-score, it will pretty much just be the same value. The only thing that will be different is instead of it being negative, it should be positive now. So this one will be positive 1.282. And that's it for that second example. Any question in regard to that second example? All right, so what I want you to do, I want you to try this last example for this one, and then we're actually going to start doing application. So application just means we're going to start doing word problem. So try doing this next problem. All right. So if you look at my drawing, I have 0.90 in the middle. So that means 90% of the middle, you have 0.05 on the left toe, you have 0.05 on the right toe. So you want to do inverse norm of 0.05. So if you do that, you should get that this one is negative 1.64, and you can just round that up to 5. This one should be 1.645. And that's it for that last problem. Any question for that last problem? All right, so let's scroll on down. Okay. So for this next problem, what we're going to be doing, we're going to be going when the mean and standard deviation is not coming from a standard normal distribution. So when our mean and standard deviation are something other than 0 and a 1. So I'm going to go ahead and show you 2 different ways how to do that. And it totally is up to you which way you want to do it. But you do kind of want to be careful about which way you want to do it. All right, so for the first way I'm going to show you is with this one, we're going to exclude step number 3. So step number 1 says draw a normal curve and shade the desired area. Step 2, convert the value of x to a z-score or standardize the data using z is equal to x minus mu divided by sigma. The last step, what we're going to do, we're going to find the area under the standard normal curve. So those are the 3 steps we're going to be taking. So let's do this first problem. So the first problem says mu is equal to 35, sigma is equal to 5. So if you look at it, it's not a standard normal distribution anymore. This is technically just a normal distribution, because now my mean and standard deviation is something other than 0 and 1. So I'm going to go ahead and do step number 1. So I'm going to go ahead and draw it. So the middle should be your mean, which is 35 now. If you look at it, this is 37. 37 is bigger than 35, so it should be to the right of 35. So we'll put 37 there. If you look at the arrow, well, not the arrow, the inequality, if you look at it, it's pointing to the right-hand side. So we want to say it's greater than. So that means you shade the right-hand side. Any questions so far on the drawing? All right, so up next, we're going to go ahead and do, we're going to find the z-score. So to find the z-score, we're going to do x, where they're telling us x is equal to 37. So we'll say 37 minus my mu, which is 35, divided by 5. So if you do 37 minus 35, you get 2. Divided by 5. 2 divided by 5 is 0.4. So we found the z-score is 0.4. So since I found the z-score of 0.4, now that means my mu is equal to 0. My standard deviation is now equal to 1. So we standardize our data set. Since we now standardize our data set, now we could assume mu 0 and standard deviation 1. So if we're drawing this out, our new drawing would look something like this, where the middle is 0. This is 0.4, and you shade the right side of 0.4, because we still want it to be greater than, but instead of it being greater than 37, now it's greater than 0.40, because 0.40 is 37. Any question for that new drawing? All right. So lastly, we're going to go ahead and do, we're going to go ahead and do the lower, the upper. We're going to say mu, and we're going to say what sigma is equal to. So if you look at the lower is 0.4. So you put lower is 0.4. If you look at the upper, since you keep on going to the right-hand side, that's technically positive infinity. So it's telling us it's going to 10 to the 10 power. If you look at the mean, since we standardize this, the mean will be equal to 0. My mu, our mu will equal to 0, and standard deviation will equal to 1. So that's what we're going to enter into our TI 83 or 84, depending on which one you have. Any question for the lower, upper, mu, or sigma? All right, so let me go ahead and find this. So I'm going to transition over to my calculator, for that way you can kind of see what I'm doing. So we'll say standard. So let's go second. We'll go to bars. We'll go to normal CDF. So for my lower bound, we said was 0.4. For my upper bound we said is 10 to the 10 power. My mu, since we standardize it, my mu is still 0 and my sigma is still 1. So we go to paste. You go to enter. And that's the probability that x is greater than or equal to 37. So we'll say 0.3446. So that's our answer. And let me go back to my work pad, for that we can see the work that, or how I wrote it. Right. So that's your answer for A. Any question in regard to A? All right, so up there we're gonna go ahead and do B, and B, I'm gonna show you a different way how to do it. Technically, B should be a shorter way how to do it, but it kind of depends how comfortable you are with it or not comfortable. So it depends on you. So if you look at B and if you look at A, the only thing different between A and B, A has an equal sign, B doesn't have an equal sign. But if you kind of remember, it doesn't matter if we include the value or don't include the value, since this is a continuous data set, it shouldn't make a difference. So what we're gonna do for this one, we're not gonna find the z-score, we're not gonna standardize the data set, we're actually gonna leave it where the mean and standard deviation is 35 and 5. So what we're gonna go ahead and do, we're gonna just jump right into normal CDF. Oh, so we're gonna say, what is our lower? What is our upper? What is the mu? And what is the sigma? So for this one, what we're gonna do, we're gonna look at this drawing over here, and we're gonna get what is the lower value. So if you look at the lowest value that gets shaded, technically it's 37. So we're gonna put 37 is the lower value. If you look at the highest value that gets possibly shaded, since you keep on going to the right-hand side, we're gonna say the upper is 10 to the 10 power. If you look at the mu, since we didn't standardize the data set by finding the z-score, the mu would remain the same. So mu would still be 35. So that means standard deviation will be equal to 5. Any questions so far? I got the normal CDF, a lower is 37, upper is 10 to the 10 power, mu is equal to 35, and sigma is equal to 5. All right. So let me go ahead and go over to the calculator and let's get our answer. So we're gonna go second, bars, we'll do normal CDF. So for the lower bound, we said it could be 37. My upper bound is actually gonna be 10 to the 10 power, so I can just leave that. My mu, we're changing our mu to now 35. And we're changing our sigma to now 5. So that way the calculator now knows it's not a standard normal distribution. Now is a normal distribution. So now it will do the adjustment for us. And if you press enter, if you look at it, it should have given us the same answer. Well, it does give us the same answer that we got before. If you look at this first one, that's the answer that I got before. If you look at the second one, this is the answer I got right now. So we get the probability x is greater than 37 is equal to 0.3446. So that's the second way of how you could find the answer for this one. So you kind of depend on you, whichever way you want to do is okay with me. Any question for the last prompt?
So if we can just enter the numbers as they stand, what's the point of converting it to standard first?
Well, the point of converting to standard first, it was kind of before we had the technology. So, because they used to use something called a t-table, and the t-table, well, sorry, the z-table, and the z-table had all of the z value. So the reason why you want to standardize the value, because you want to find what is the z value, so that way you can just use that table. So it was just a fact that you only have one z-table, and the z-table had all of the different z value from negative 3.49 all the way to positive 3.49. So if you had a mu of say 35 and 5, you couldn't just look for like the number 37 to see the probability. But now since we have technology, it kind of made it obsolete where you don't really need to find the z value because the technology will find the area for you.
Good to know.
Yeah. All right. So let's do C and D, and then well, let's do C, D, and E, and then that should be it for today. All right. So up next, we're gonna do probability that X is less than 24. So we'll go ahead and do this. So 35 should be in the middle. If you look at 24, 24 is to the left of it. So you shade the left side because it says less than. So we're gonna go ahead and do the lower, upper, mu, and sigma. So for this one, what will be the lower? Well, if you kind of look at it, it keep on going to the left-hand side. So since you keep on going to the left-hand side is negative infinity. So it'll go negative 10 to the 10 power. If you look at the upper, it get cut off over here at 24. So you put 24. If you look at mu, mu will be equal to 35. Sigma will equal to 5. All right. Everybody good so far on those notation that the lower bound, upper bound, mu, or sigma? All right, so I'm going to go ahead and do this in my calculator. Negative 10 to the 10 power. Mu is equal to 24, mu is equal to 35. Right. So if you actually go ahead and do this problem, you should get the probability that X is less than 24. Well, this is equal to 0.0139. All right, and that's it for C. Any question in regard to C? All right, so what I want you to do, I want you to practice on D and E. Technically for one of them, you shouldn't really need to do any type of work. You should be able to see what the probability is. So try doing D and E and let me know what you get on the chat. Let me. All right, so let me give you the answer for the first one. Oh, let me turn it off. 16026. So that should have been the answer for the first one. So the answer for the first one should have been 0.6026. If you do that, the lower bound should have been 33.7. Upper bound should have been 10 to the 10 power. My mu should have been 35, and sigma should have been equal to 5. For part E, if you look at part E, it said what the probability x is less than 35. If you kind of remember, 35 is the mean. So it's saying what's the probability something will be less than the average. So something is less than the average. That means it should be 50%. So that's all you had to do for part E. You put 0.50 because anything less than 35, which is the average, you should have 50% less than the average, 50% above the average. And that's it for that last part. Any question in regard to part E?